These are the notes for the quiz that we took on Friday on related rates. I'm going to do this problem first in a manner that I think is the quickest way to do it, and that is to work with the major axis. To note that what I'm looking for in this problem is the rate that the major axis is changing, and what I'm given is b, and I'm given the rate that the area is changing. So if I'm going to relate the major axis rate to the area rate, I want to take this formula right up here and rewrite it so that it's in terms of the area. I've already got the area, but I want to take this here and write it as in terms of the major axis. So the way that I'm going to do that is I'm going to define a new variable called u, and u is going to be equal to the major axis, which would be 2a. And by the way, if u is equal to 2a, then that means that u is also equal to 4b. I can rewrite this solve for a, which would mean a is equal to the major axis divided by 2, and b is equal to the major axis divided by 4. And while I'm working with b here, the place where I'm interested in these rates is right here when b is equal to 12. And if b is equal to 12, so if b is equal to 12, then that would mean u would be 4 times 12. So I'll make a little note for myself over here that where we're interested in is the point where u is equal to 48. Right? So this whole problem revolves around when it is that u, the major axis, is equal to 48. So now my defining equation, a is equal to pi times a. A is u over 2. So this is u over 2. And then b, well, b is u over 4. So this is u over 4. And then I can multiply that out, and my defining equation that shows the relationship between the area and the major axis is pi over 8 u squared. And now what I'm going to do is I'm going to take this equation and I'm going to watch what happens when I take the derivative of this with respect to time. So I'm going to end up with dA dt is equal to, this will be 2 times pi over 8, which would be pi over 4, u to the first, and then using the chain rule, du dt. Now the next step is to substitute in what I know. Right? So I know that dA dt is 144, and I know that u is 48. So I then get dA dt is 144, and it's decreasing, so it's negative. This is equal to 48 over 4. Actually, I'll just leave it as 48 pi over 4 du dt. And now I'm just going to divide both sides by 48 pi over 4, and I get my answer, which is negative 12 over pi. Right? Du dt, and the units on this are centimeters per second. Right? So again, this is the most efficient, quickest way to solve this problem. There are other ways to do this problem, to go back to do it the way that we did it originally. Alright, so now quickly is quick. So we'll do this again here. So Many people started with the defining ratio, or excuse me, relationship, a is equal to pi a b, took this and took the derivative of this with respect to time, which gives you dA dt is equal to pi times, and now this is a times b, so we're going to need to use the product rule. So this would be the derivative of the first, which would be 1 times dA dt, right, derivative of the first times the second, plus the derivative of the second, dB dt times the first. Right? So all of this here is the derivative of the first times the second plus the derivative of the second times the first. Now at this point I know what dA dt is. I know what b is. I'm sort of looking for dA dt. If I can find dA dt, it's pretty straightforward to figure out what d2a dt is going to be. But what I don't know is what dB dt is. Right? And there are two ways you can do this. One way would be to just simply take this relationship where a is equal to 2b and take the derivative with respect to time of this, and you would get dA dt is equal to 2 dB dt, or dB dt is equal to 1/2 dA dt, and then at this point you could take this right here, 1/2 dA dt, and plug it in right here for dB dt, and then you plug in you plug in 12, and you plug in negative 144 here, and then you would solve the whole thing for dA dt. Another way that people did this was to go back to the defining relationship, a is equal to pi a b, and then notice that a was equal to 2b, and we end up with a is equal to pi times 2b times b, or a is equal to pi 2b squared. And then if you take the derivative with respect to time, if you take the derivative of this with respect to time, there we go, my notation is caught up with my vocabulary, you will end up with dA dt equals 4 pi b dB dt, or dB dt is equal to dA dt all divided by all of this over here, which is 4 pi b. Now, you know what b is, you know what dA dt is, so you take all of this, and then you can take whatever this value ends up being and plug it back in here for dB dt, and then solve this for dA dt. Right? So again, it's workable, but it involves an enormous amount of calculations that you don't really need to be doing. The much quicker, more quiz. Alright, so now we're on the back side. I'm going to take and, since I'm going to end up using this equation s squared plus plus w cubed equals 7, I'm going to end up using this 4 times. I'm going to rewrite it right here. S squared plus w cubed equals 7. And what I'm looking for, originally, ds dw, so that means that I want to take the derivative of this with respect to w. So if I take the derivative of this with respect to w, I get d dw, and then when I do this out, this is going to be 2s ds, that's an s, ds dw plus 3w squared dw dw, which was going to equal, and then I take the derivative of 7, which is a constant with respect to w, so that's going to be equal to 0. And now, again, I'm looking for ds dw, which is right here, so I subtract, actually let's do this really quickly, dw dw is just simply 1. So now I'm going to solve, again I'm solving for ds dw. I want to bring the 3w squared over onto the right side, and then I'm going to divide that by 2s, and what I will end up with is minus 3w squared all over 2s. Right? Many people solve this problem by first writing s, solving this equation up here in terms of s, right? So there would be this step where they would say that s is equal to the square root of 7 minus w cubed, and then take the derivative of this with respect to w, so ds dw, which would be doing explicit differentiation here of that, and you'd have to think about this as 7 minus w cubed raised to the 1/2 power, and you do the power rule, and you can end up with a version of this where the s is written in terms of w, and long and short of it, doing the explicit differentiation is longer. Doing the implicit differentiation is shorter. All right, so the short way to do this second problem here, again, I'm just going to rewrite this s squared plus w cubed equals 7. I'm now looking for the derivative of this with respect to s. When I do this, I get 2s ds ds, just leave that as 1, don't even bother writing it down, plus 3w squared dw ds is going to equal 0. And again, I'm in this same position where I'm looking for dw ds, subtract 2s from both sides, divide by 3w squared, and very quickly and efficiently I have my answer, which is negative 2s all over 3w squared. All right, moving on to the last two problems. The last two problems I can do, actually I'll do this once and then solve, actually here, let me just write s squared plus w cubed equals 7. In both of the last two problems I'm looking at how something changes with respect to t, so I'm going to take the derivative of this with respect to t, which is going to give me 2s ds 2s ds dt plus 3w squared dw dt equals 0. And for dw dt, I'm going to take I need to solve for dw dt, which is right here, which means I need to take this, subtract both sides, subtract negative 2s ds dt from both sides, and then I'm going to divide by 3w squared, which is going to give me minus 2s ds dt, and then all of that gets divided by 3w squared. And yes, you can write this as minus 2s ds all divided by 3w squared dt. And then the last one, I'm looking for ds dt. Subtract all of this from both sides, and then divide by 2s. Final answer being negative 3w squared dw dt, all divided by 2s. And that's it for the quiz.